All right, let's continue with question number 5 and 6 from the Ready to Go On quiz. Question 5 and 6, we're looking for the lateral and the total surface area of each figure using its net. So because it's asking for the total surface area, I'm going to start by finding my area of my base or bases. I'm going to need that to find the total surface area. If it were only asking for the lateral area, I wouldn't bother with finding the base. For this shape, I need to figure out what the base is. Well, what shape is this? I see lots of triangles, so I know it must be a pyramid. And there's no squares, so it must be a triangular pyramid. Triangular pyramid has a triangular base. That's what the first word means. So I've already put it here. My base is going to be 1/2 base times height, because that is the area of a triangle. I can go ahead and look at my reference sheet for that one. Area of a triangle, 1/2 base times height. So I put that here. Now I just got to plug in my numbers. What is the length or the base of my triangle? That is this base right here. How long is it? Well, it's 24 meters. So that's going to be 1/2 of 24. And the height of this triangle base is 15 meters. So 1/2 of 24 times 15. Well, let's see, half of 24 is 12. And 12 times 15 is, well, let's work out over here real quick. 2 times 5 is 10. 2 times 1 plus 1 is 3. 1 times 5 is 1. 1 times 1 is 1. 180. Okay? So 180 square meters, because I'm multiplying two things together in this area. That's my base. All right. My question's not asking for the base, though. But if it was, I'd have it right here. My question is asking for the lateral area. So that's going to be everything that's not the base. That's going to be these three triangles. Luckily for me, they're all the same size. So that's going to be pretty easy to find here. My lateral area is going to be, there's three of them, they're all the same size. What are they? Well, they're all triangles. So again, I'm going to use that formula, 1/2 base times height. In this case, for these side triangles, their base is, well, let's see, their base is this length right here, 24. Their height is 40. So let's see, half of 24 is 12. Twelve times 4 is 48. So add a 0. And multiply that by 3. Let's see here, that'll be 1200. No, sorry, 3 times 400 is 1200, right? 3 times 80 is 240. Add those together, I get 1440. So my lateral area is 1,440 square meters. My surface area now is equal to your lateral area, your sides, plus your base. So if I just add 180 to this thing, I'll get my surface area. So let's see, 180 plus, that would be 1620 square meters. Okay, so there's my answers. Lateral area is 1,440 square meters. My surface area is 1,620 square meters. Number 6. So first I have to identify, again, I found a lateral surface area, so I'm going to find the area of my base, or bases. Okay, in this case, my bases, it doesn't really tell you, which is always tricky with the rectangular prism, because anything can be your base. But I'm going to assume for this problem that these are my two bases. So if that's true, remember prisms always have two bases. If that's true, I can find these areas by, let's see, length times width, because they're rectangles. I'm going to use the formula length times width. The one on the reference sheet is base times height, but you should be comfortable using either one, right? So the area, I'm sorry, actually, you know what? I'm missing something here. There's two of them, aren't there? There's two bases. So my area of my base is going to be length times width times 2, because there's two of them. All right, the length of this squarish thing, it's not square, but it's more of a square than these guys. The length of this bigger rectangle is 12 inches. The width of this big rectangle is 10 inches, and there's two of them. So 12 times 10 is 120, times 2 is 240. That is the area of my bases, both of them. All right, so my lateral area now is going to be these rectangles. So let's go one by one, see what we got here. This rectangle, start right here. Okay. And I'm going to go ahead and I'm going to label my drawing. This is a very good habit to get into while you're working on these kind of problems. Go ahead and put your areas on top of that shape. Okay, you'll notice how I label my bases. I'm also going to label their area. So this area right here is going to be length times width. So how long is this rectangle? Well, it's 12. How wide is it? That is, it's going to be 6. So my area is 12 times 6, which is 72. All right. Next rectangle, this one. Length times width. Let's see, 6 times 10, 60. Next rectangle. Let's see, 12 times 6. Hey, we did that one before, 72. And this one, 6 times 10. Hey, we did that one before too, 60. All right. So now if I add up my 4 sides, not my bases, just my 4 sides, I'll get my lateral area. That's going to be 72 plus 72 plus 60 plus 60. That's going to be, let's see here. 72 plus 72 is 144 plus 120 for 60 is 264. 264 what? Dollars? No, I don't think so. 264 square inches. Length times width. All right, and my total surface area is going to be the same thing as my lateral, but I'm going to add my 2 bases to it. So if I add 240 to 264, I will get, you know what, I'm going to go ahead and just add it right here so I don't make any mistakes. Looks like 504. All right, and we'll go ahead and just answer question number 7 real quick. You can come up with some ideas on your own, how you use volume and surface area to solve real world problems. I'll tell you, anybody who, there's a lot of these things. If you paint, you have to know surface area. If you box anything, you have to know volume and surface area. If you are moving and you have to move your furniture around, you have to know how the volume fits. If you are moving and you have to use a moving truck, you have to know how much volume your truck contains and whether or not your possessions require that much volume. I mean, there's lots of these guys. Come up with some more on your own. Right? There's lots of ways we use volume and surface area in the real world.